Chapter 5 of Dynamic Thought, or the Law of Vibrant Energy, by William Walker Atkinson. This LibriVox recording is in the public domain. Recording by Sandra Knight, www.sandraknight.net. The Story of Substance. As we stated in a former chapter, there are two aspects of all things, viz. 1. Substance, 2. Mind. In this and the following two chapters we shall consider the first one, substance, which science calls matter. Perhaps it would be as well to begin by asking ourselves the question, what is substance? The answer seems to be anything that takes up room, the body aspect of things, matter occupying space, etc. Some writers have spoken of substance as something tangible that can be felt. But this definition will not do, for there are forms of substance too fine to be felt, and so perhaps the definition, the body of things, is as good a definition as any, taken in connection with the thought that it takes up room. Science divides substance, which it calls matter, into four general classes, viz. 1. Solid matter, which is substance, the parts of which closely adhere and resist impression, such as stone, wood, flesh, etc., the degrees of solidity varying greatly, and sometimes shading into the next class, which is called 2. Liquid matter, which may be described as substance, the parts of which have a free motion among themselves and easily yield to impression, such as water, molasses, etc., the degree of fluidity ranging from some liquids that flow very slowly, such as hot pitch, up to others that flow very freely, such as water, wine, etc., the property of fluidity being also shared by the next higher class, which is called 3. Aeriform matter, which is substance in the form of elastic fluid, such as air, gas, vapor, etc., and radiant matter, which is of recent recognition and which is an ultra-gaseous form of substance utterly unlike anything ever before known, consisting of the tiniest particles of corpuscles of substance finer and more subtle than the rarest form of atomic substance known to science. The three classes are well represented by 1. Earth, solid, 2. Water, liquid, 3. Air, aeriform, 4. The corpuscles or electrons or particles of electrified substance, first noticed in connection with the X-rays, radium, etc. But it must be remembered that these four classes of substance are not fixed or permanent. On the contrary, they are changeable either under pressure when subjected to heat or under the influence of electricity, etc. In fact, the word condition is more applicable than the term class. The condition or class of a particle of substance may be changed into another class or condition by the application of the agencies above named. The same substance may exist in 2 or 3 classes under different circumstances. Solids may be changed into liquids and liquids into gases, and vice versa. Metals may be melted, then changed into gas, according to the degree of heat applied. Liquids may be changed into vapor by the application of heat, or into solids by the withdrawal of heat. For an example, we may turn to water, which is a solid in the condition of ice, a liquid in the condition of water, and steam in the condition of vapor. Quicksilver is a metal which is in a liquid condition in our ordinary temperature, but which becomes a solid when subjected to a very low degree of temperature, and may be transformed into a gas under a high degree of heat. Air is a vapor in our ordinary temperature, but has been transformed into liquid air under tremendous pressure, which produced a very low degree of temperature, and theoretically it may be transformed into a solid under a sufficiently low degree of temperature, although so far science has not been able to produce a degree of cold sufficient to freeze the liquid air. It is all a matter of freeze, melt, and evaporate in all forms of substance, and any substance, at least theoretically, is capable of being subjected to any of the 3 conditions just named, and being manifested in the respective conditions of solid, liquid, and aeriform. This may actually be accomplished with the majority of substances at this time, although in some instances we are not able to produce a sufficiently high temperature to melt and evaporate certain solid substances, on the one hand, or a sufficiently low degree of temperature to liquefy or freeze solid certain vapors. But the intense heat of the center of the earth is able to melt rocks and show them as liquid lava flowing from volcanoes. And science teaches that the solid substance of the earth and other planets, suns, etc., existed in the shape of a vapor at one time, and would again take on that condition in case of a collision with another great body, which convert motion into intense heat that would first melt and then vaporize every solid particle of which the earth is composed. If the sun's heat were completely to die out, the cold would be so intense that the air around the earth and all the gases and vapors would be frozen to solids. In physics, the term gas is generally applied to a substance that is aeriform in ordinary temperature, but which may be liquefied in a low temperature. The term vapor being generally applied to the aeriform condition of substances that are solid or liquid in our ordinary temperatures, but which may be evaporated by heat and thus transformed into an aeriform condition, resuming their original form upon cooling. These terms, however, are technical, and practically there is no difference between a gas and a vapor. In the above statements regarding the possibility of the transformation of each of the several forms of substance into other forms, the reference has been applied only to the three better forms, i.e., solid, liquid, and aeriform. The fourth form, or state of substance, known as radiant matter, is of too recent discovery to admit of its properties being accurately observed. The best and latest opinion of science, however, is that it constitutes what may be called primal matter, that is, substance from which all other forms, states, kinds, and varieties of substance arise, the stuff from which they are manufactured. Science seems to be discarding the ether theory of the origin of matter in favor of this primal matter. Physical science divides substance into masses, molecules, and atoms. That is, the old physical science did. But the later investigators now see that even the atom may be subdivided. But the old terms may as well be used, at least for the time being. Let us consider these divisions. A mass is a quantity of substance considered as a whole, but which is composed of a collection or combination of parts, molecules. A lump of coal, a piece of iron, a portion of meat, even a drop of water, is a mass. The only requisite for a mass is that it contains two or more parts or molecules. Therefore, a mass is a collection or combination of two or more molecules considered as a whole. A molecule is the physical unit of substance, or, in other words, the smallest part of any kind of substance that can exist by itself and still remain that particular kind of substance, but not the smallest chemical part. The latter is called an atom, and atoms combine to form a molecule. The molecule exists as a unit and cannot be split or separated by physical means, although it may be separated into atoms by chemical means. In order that we may form a clear idea of the molecule, let us take a very small mass of matter. A drop of water, for instance. This drop of water is a mass composed of a great number of molecules. It may be divided and subdivided into smaller and still smaller parts. This division may be carried on until it reaches a point where our sight and instruments are unable to make a further subdivision. But theoretically, the work may be carried on still further until at last a limit is reached where we are unable to divide the water into any smaller parts, without separating its chemical constituents from each other, in which latter case there would be no water at all. Its chemical constituents, or atoms, having separated and now appearing as two atoms of hydrogen and one atom of oxygen, separated and apart and no longer forming a molecule of water. Well, this smallest possible part of water, or any other form of substance, is a molecule. Remember, the molecule is the smallest part of that kind of substance that can be produced by division and subdivision without destroying the kind of the substance. It is the smallest part of any kind of substance that can exist by itself and maintain its kind. In order that you may grasp the minuteness of the molecule, we may mention that science claims that no molecule, even the largest, is of sufficient magnitude to be seen under even the strongest microscope. It has been calculated that if a drop of water as large as a pea were magnified to the size of the earth, the molecules would then appear no larger than the original drop. The space between the molecules is believed to be considerably larger than the molecules themselves. The figures that are necessary to use in connection with molecular substance are likely to stagger the imagination. Besides speaking of the molecules of inorganic substance, it may be interesting to note that a spider's thread is so fine that a piece of it large enough to circle the earth would weigh only half a pound. And yet each thread is composed of 6,000 filaments. And each of these minute filaments may be divided into tiny bits, and each bit will still be a mass of substance containing thousands of molecules and their constituent chemical atoms. There are living, microscopic creatures so small that 5 millions of them might be crowded into a space the size of a pinhead. And yet each of them have organs, and in these organs fluids circulate. Try to figure out the size of the molecules of the fluids circulating in these tiny organs, not to speak of the chemical atoms. When you handle a coin, an infinitesimal portion of it is worn off. Can you figure the size of the molecules composing that part? When a rose throws off its perfume, it emanates tiny particles of itself. Can you measure or weigh the molecules composing that odor? The human mind is compelled to realize the finiteness when it considers these things. But we have only just begun to consider the smallness of things. An atom is the chemical unit of substance, that is, the smallest chemical part that can enter into combination. It has been considered indivisible, that is, incapable of further subdivision. That is, it has been so considered until very recently, but the latest discoveries have exploded this idea and have shown the atom is composed of certain other things, as we shall see a little later on. Still, we may use the atom as a very good unit of measure, for it still represents the unit of chemical substance, just as the molecule is the unit of physical substance. In order that you may understand the difference between molecules and atoms, physical units and chemical units, let us give you a few examples. Take a molecule of water, the physical unit, you remember. When it is chemically separated or analyzed, it is found to contain 2 atoms of hydrogen and 1 atom of oxygen. Both chemical units, remember, which when united and combined form water, but which when separated are simple atoms of certain chemical gases. The proportion in water is always the same, 2 of hydrogen and 1 of oxygen. This is the only partnership that will form water. The molecule of table salt contains 1 atom of sodium and 1 of chlorine. The molecule of air contains 5 chemical gases, of which nitrogen and oxygen are the principal ones, the proportion being about 3 parts of nitrogen to 1 of oxygen. Some molecules are far more complex. For instance, the molecule of sugar is composed of 45 chemical atoms, and sulfuric acid of 7. An atom is estimated at 1/250 millionth of an inch in diameter. But this is not all. The old theory of the finality and ultimateness of the atom has been shattered by the recent discoveries of science. The atom of hydrogen was formerly considered to be the refinement of substance, the ultimate atom, the smallest and finest atom possible or known, the last thing that could be imagined about substance. Some even went so far as to declare that the atom of hydrogen was the ultimate element. That is, the element out of which all other atoms were made, the mother of atoms. It was supposed that all other atoms of matter were composed of a varying number of hydrogen atoms, which themselves were vortex rings in the ether, and that analysis could go no further. Science rested on its oars and pronounced the work of a century completed. But alas, no sooner was the position reached than the discovery of radiant matter and the formulation of the corpuscle theory brought down the whole theoretical structure, and science was compelled to take up the hunt again, and to probe further into the inner recesses of things for the ultimate thing. but nevertheless atoms still exist, although their finality is no longer urged. The facts remain, although the theory has fallen. Let us see about this latest theory, the corpuscle or electron theory. The discovery of radiant matter and the investigation of the late discovery of radium has led to the further discovery that each atom, instead of being a thing in itself, is a little mass containing numerous other things called corpuscles or electrons because electrified. The theory is this, briefly, that each atom is a minute mass of substance containing a number of electrified particles which are known as electrons, in constant motion and vibration, revolving around each other as do the planets, suns, and moons of the universe. In fact, each chemical atom is like unto a universe in itself. The simplest atom, that which was supposed to be the ultimate atom, the atom of hydrogen, is supposed to contain within its tiny self no less than 1,000 minute corpuscles, which because electrified are called electron, revolving and fixed in regular orbits within the containing globe of the atom. The more complex forms of atoms are supposed to contain a far greater number of electrons, the authorities estimating those in an atom of oxygen at 10,000, those in an atom of gold 100,000, and those in an atom of radium 150,000. These figures are of course mere scientific guesses, but when compared with the similar guess regarding the size of the atom, they give a startling illustration of the size of the newly discovered corpuscle or electron. Another authority for an illustration asks us to consider a great globe about 100 feet in diameter, that is, of course, 100 feet through its center. Let the globe represent the atom. Then imagine 1,000 minute specks, each the size of a pinpoint, composed of substance, and each containing, as in a capsule, an atom of electricity. Each speck is revolving around each other in a regular orbit in the great 100 feet through globe, and keeping well away from one another. That will give you an idea of the relative size of the electrons and atoms, and the room that the former have to move about in. Good many feet between each, you will notice. Lots of room and plenty to spare. Try to figure out the size of an electron. Many readers of the magazines have been confused as to the relation between the corpuscles and the electrons, or ions as some have called the latter. The matter is very simple. They are both the same. The corpuscle is the tiny particle of matter, which because it is electrified and has thus become the unit of electricity, is called an electron. From the viewpoint of substance, we call the tiny particle a corpuscle. From the viewpoint of electricity, we call it an electron. These electrons are the tiny particles that pour forth from the pole in the Crookes tube and constitute what are known as X-rays, cathode rays, Becquerel rays, etc. They also are the particles that are thrown off and emitted by radium and similar substances. They exist in the atom, as explained, but also are found free and independent, and in the last condition or state are thrown off in the aforesaid rays and by radium, etc. So far, the corpuscles are known only as charged with electricity, and the electron only as a tiny charge of electricity with which the corpuscle is charged. But science dreams of corpuscles of substance other than electrons, in which case the old occult teachings of light dust and heat dust, etc., will be verified. The electron contains a powerful charge of electricity, as much in fact as an atom 1,000 to 150,000 times its size will carry. But science is wondering how these highly charged particles manage to hold together in the atom, so rigidly coherent as to appear indestructible. We think that we may get a hint at the matter a little later on in this book. Science, or at least some scientists, are wondering whether the whirl or vibration of the corpuscle might not produce that which we call electricity, and whether, when the motion is intensified, waves of electricity will not be emitted. The writer fully agrees with the idea and finds that it fits closely his own theories regarding substance and motion. But the reader is cautioned against falling into the error of many recent popular writers on the subject, some of whom have used terms calculated to convey the idea that the corpuscle, electron, is electricity itself, rather than tiny particles of substance called corpuscles, charged with the unitary charge of electricity and therefore called electrons. But for that matter, electricity is only known to us as associated with some form of substance and not as a thing in itself. We shall see the reason for this as we proceed with this book. These corpuscles are destined to play a most important part in the theories of science from now on. They already have overturned several very carefully and laboriously erected theoretical structures, and many more will follow. Among the many important ones evidently doomed to the dust heap being the vortex ring atom theory, and other theories built upon the etheric origin of matter, and other theories concerning the ether, even to the extent of breaking down the theory of the ether itself, which theory had almost come to be considered a law. We shall further consider the corpuscles and their qualities, characteristics, etc. in the next chapter, for they have an important bearing upon the theories advanced in the course of the study of this book. End of chapter 5.